Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will review everything you need to know about measurement for the upcoming test. So we're focusing on the volume and surface area of 3D objects. That includes prisms, tapered objects, spheres, and composite objects. So let's look at this problem here. I have this half pipe here. I'm sorry, I know it's very poorly drawn. It's supposed to be a trapezoidal prism with like half a cylinder cut out. So we're going to calculate the volume of concrete needed to make this, and then we're going to calculate the cost to paint it. So let's start by calculating the volume of the concrete needed. All we need to do is calculate the volume of this shape. Now it may not look like it, but this solid is actually a prism. That's because we have this weird shape here repeated at the front and the back. There is a consistent cross section and also a whole heap of rectangles. That's why this is a prism. So if we identify that it's a prism, we can use for volume the formula V equals AH, volume equals area of the base times the height. So when we talk about the base, it doesn't necessarily mean the face that is on the bottom, it means the face that is repeated, the cross section that is consistent. So for this shape here, this here would be the base. So all we need to do is find the area of this base and then multiply by the height. Now when we say the height of a prism, we mean the dimension that is perpendicular to the base. So we're just going to go area of this base times by 3. So this is a trapezium with half a circle cut out of it. That is the base. So the area of the base for a trapezium, its perpendicular height of the trapezium divided by 2 multiplied by the sum of the two parallel sides. Well, this parallel side is 12. This one up here is 4 plus 2 plus 2, which is 8. So this here is the area of the trapezium, and now we need to subtract the area of this semicircle here. So the area of a circle is pi times radius squared. Here 4 is the diameter, so the radius is half of that, which is 2. So that's the area of a circle, but because it's a semicircle, we need to divide by 2. So I'm going to write this as 40 minus 2 pi, because that is the exact area. Whenever you are going to use a number in a subsequent step of a calculation, we want the exact answer. We're going to now multiply this by 3, so I don't want to round my answer here and introduce inaccuracies into my calculations. The volume is just going to be area of the base multiplied by 3. So putting this on our calculator, we get about 101.15 meters cubed. So that's all there is for the volume. Please pause and copy down if you want this, because I'm going to rub it out now and calculate the surface area. So to answer this question about the cost to paint it, we need to know the surface area. Surface area of a solid is just the area of each of its faces added up. So let's go ahead and calculate the surface area. Now for any prism, you can use the formula 2a plus ph. So in this formula, A is once again the area of the base, so this thing that's shaded in yellow. P means the perimeter of the base, and once again H means the perpendicular height of the prism. In this case, it's 3. Now, when we were finding the volume, we already calculated that the area of the base was 40 minus 2 pi. It was the trapezium, subtract the half circle. Let's go ahead and calculate P here. So P is the perimeter all the way around the edges of this base. Now to do that, we're going to need Pythagoras theorem. Sometimes you need that. So here and here, we will have 2, and we know the perpendicular height is 4. So using Pythagoras, this slant height here will be the square root of 4 squared plus 2 squared. It will be the square root of 20. So the square root of 20 is about 4.47, but I'm going to leave it in exact form because I'm going to use it in the next step. The perimeter of this shape, you can see, is 12 plus root 20 plus 2 plus 2 plus root 20, and we have to add in this bit here. So I've got 12 plus 4 plus 2 root 20, and we'll calculate this arc here. So the circumference of a circle is 2 pi r, so here r is 2, but once again we divide by 2 because it is half a circle. So the perimeter of the base is actually 12 plus 4, which is 16, plus 2 root 20 plus 2 pi. So for the total surface area, we have 2 times A, so 2 times this, plus perimeter times height. Let's put all of this in our calculator. So we get about 161.116 meters squared, but this surface area includes all of the faces, including the bottom. We didn't actually want to paint the bottom. So the area to be painted, I need to take that total surface area and subtract the bottom, which is 12 times 3. The area to be painted is 161.116 minus 36. It's 125.116 meters squared. So since each litre covers 5 meters squared, you divide that by 5, you end up getting about 25.02 litres required. So how many cans of paint would we need to buy? Well, if we bought 5 cans, we'd have only 25 litres. We'd be a tiny bit short. So we actually need to buy 6 cans, and if they cost $96, that will cost us $576 in total. All right, let's look at some more problems. So here we're told that the sphere below is inscribed in a cylinder. That means the sphere fits perfectly in the cylinder. It's touching at all of these places. Sorry, I know I'm a terrible drawer. So we're told the cylinder holds 3 litres. How many litres does the sphere hold? So let's start by letting r be the radius of the sphere. That means it's also the radius of the cylinder. So that means the diameter of the sphere, which is also the height of the cylinder, will be 2r. So what we have here is the volume of the cylinder equals area of base times the height. So it will actually be 2 pi r cubed. We know that the volume of any sphere is 4 over 3 pi r cubed. Now, if I divide this by this, then I can cancel out the pi's and the r cubes. I'm left with 4 over 3 divided by 2 is 2/3. What the hell am I doing? What has this got to do with anything? Well, I've just shown that when you have a sphere inscribed in a cylinder, the volume of the sphere is exactly 2/3 of the volume of the cylinder. So that always works. In fact, that's how the formula for volume of a sphere was discovered. It's just 2/3 of the volume of the cylinder in which it's inscribed. So if the volume of the cylinder is 3 litres, the volume of the sphere is just 2/3 of that is 2 litres. All right, one more problem to do and then we're done. So this wooden log here is going to be placed in this pool. The pool currently contains 6,000 litres of water, and we need to find whether or not the pool will overflow. So let's calculate the height of the water in the cylindrical pool currently. So note that 6,000 litres is 6 metres cubed. 1 metre cubed is 1,000 litres. So what would be the height of the water? It wouldn't go all the way to the top, but to find the height of a prism, a cylinder is, for all intents and purposes, a prism, we just take the volume and we divide by the area of the base. Remember, for a prism, the base is the shape that is repeated. So the base of a cylinder is this circle here. So the area of that circle is pi times radius squared. So we have that the height is about 1.91 meters currently. So the volume of the log, very easy to figure out. It's a rectangular prism, so we just multiply the dimensions together. 1 meter by 60 centimeters by 40 centimeters. The volume of the log is 0.24 meters cubed. So that means if I put the log into here, the volume of what's inside the cylinder will increase by this amount. So by how much will the height increase? Well, we'll just do the same calculation. The volume divided by the area of the base gives you the height. So if we put that on our calculator, we get about 0.076 meters. That's by how much the height will increase. So after the log is placed in, the height will be this plus this. You can see that these two numbers are less than 2 meters, so the answer is no, the pool will not overflow. Alright, thank you so much for tuning into this video. Best of luck studying for your exam, but you'll ace it. You're a superstar. This has been the luckiest maths teacher in the world. Have a great day.